DraftLogic Electrical's automated circuiting is a very powerful tool. You can make the setup for it either very easy or very complex at your discretion, depending on exactly what devices you want circuited where. There's a number of different types of circuiting areas and a number of different destinations for circuiting areas. And, as in all other phases of work of DraftLogic Electrical, there's the Circuit Manager, a tool to allow you, the user, to do manual circuiting work either from scratch or to modify the results of automated circuiting. Now that we have all or most of our devices in the drawing, we're ready to set up for circuiting. Fear not, if you add or remove devices later, you can rerun automated circuiting as many times as you want, or just use the Circuit Manager to manually tweak the circuiting. As with the other phases of work in DraftLogic Electrical, circuiting has its own section within the Command tool palette, and the tools within the circuiting section are arranged in the typical order that you might need them. So first of all, we see the Create Service Areas. There's 5 different types of service areas. A mixed type of service area will attempt to grab all utilization devices and service them to the same panels if the voltage is compatible. A segregated service area type will still grab all utilization devices and try and service them, but they'll be serviced by different panels. A lighting-only service area type will grab just the lights. Other only will grab just receptacles, small motors, heaters, and the like. An emergency will only grab emergency-powered devices. Service area types that will be attempting to grab the same utilization devices cannot be overlapping. You'll get error arrows letting you know when you've done that. On the other hand, service area types that are not looking to grab the same utilization devices can overlap. For example, emergency can overlap all the other ones because it's only going to grab emergency powered devices. And lighting only can overlap other only because they're after different devices. Mixed and segregated, on the other hand, cannot overlap each other, nor lighting only or other only, because there'll be a conflict about where you want a certain type of utilization device service to. So for our sample here, I'm going to choose a lighting only service area. Since my lighting is 277 volt, I'm comfortable running it to the same panel room for the whole drawing. Down on the command line, I'm asked to select the panel room ID, or the panel to use for the service area. Since I want DraftLogic Electrical to place most of my branch circuit panels, I'm going to just select the panel room ID. Next question is select the wall you wish to auto-place the panels on. I'll have DraftLogic Electrical start placing panels here. And now I'm asked to identify the service area polygons. This can be an arbitrary line that I draw using the Draw a Polygon choice, which I would choose by doing D-Enter, or I can select existing and use room, floor, or other polylines that I've already drawn, which is what I'm going to do. I'll hit Enter. I'll choose the floor boundary since I want my entire floor serviced for lighting to this panel room, and right-click to close that selection set. So it shows me in green a preview of what I've selected. I'm good with that, so I'll push F to finish. If I wasn't, I could use R to remove polylines from my selection set, or Enter to add more polylines to my selection set. Now I'll choose an Other Only. I'll select the same panel room. It already knows where I want the branch circuit panels to start being laid. And again, I'll do Select Existing. I'll use a crossing select and grab everything in the south of the drawing. Now I don't actually want this corridor, so I'll do a Shift crossing select to get rid of it. And I've decided that I want my kitchen to go to a kitchen panel, so I'll do a Shift click to take that out of the selection set. Right click to close the selection set. It greens to show me a preview. Now you see what I've done here is when I did that crossing, I included the floor boundary. Well, I don't want that because it includes the whole floor plan, and for my Other Only, I want to have about 3 or 4 panel rooms. So I need to do R to remove, click that floor boundary, right click, and now it's removed. So the green is just showing what I've selected, and I'm also going to remove this atrium. So now I can finish and continue on for this workroom in the offices area. Select existing. I'll take everything in the north here, except the atrium. Have to finish. Another other only. This storage room in the back of the gym. Now you see, once I've selected a panel room, that the other assignments show up. There's a little legend that says coloring surface areas, orange is mixed, magenta segregated, blue other. So it's letting me know that I've already assigned these polylines to be other only. That's to help me from confusing my circuit areas. Now, of course, I can override any of those selections. So here, for example, if I go select existing, and I grab all of the central area here and this corridor, which is assigned to that workroom, well, I'm going to take it too now. So right click, close the selection, and you can see that I've also reallocated that corridor to this new panel room instead. F to finish. That's done. One last one. I'll choose this smaller back room over here and grab the remaining rooms on this side of the drawing. Select existing. Right click. Finish that. So I have one room left to take care of for my other only type of circuiting, which of course is receptacles, heaters, small motors. And that's the kitchen. And in this one, instead of choosing a panel room, wherein DraftLogic Electrical will place all needed branch circuit panels as long as you've allowed it to through the Design Parameters Panels tab, I'm going to use a specified panel type service area. So to do that, I need to put my panel in first. So I'll put a recessed panel in over here, mark it up to 42 circuits. So there's my panel. Escape out of auto reload. And now I can create the service area for that. So it's other only. This time, select the panel room ID, or panel. I'm going to choose this panel. You'll notice the other assignments that have already been made for panel rooms and panels, they're green to let you know that they're already assigned. So the panel type of the panel I selected does not match the service area method selected. Do I wish to override and force it to match? Yes. So there's an attribute I'll show you in a sec, letting a panel know what type it is. And so here we are again with the preview on the circuit area selection. It's showing that every room has been assigned to other only already except the kitchen. So I'll do a right click to select existing, select the kitchen, right click to close the selection. The preview is green, F to finish, and that's done. My last one is emergency. I want to circuit my emergency devices to a separate room just to show you how that works. So I'll put them in here, panels start here, and for the service area, I'll select existing. I'm going to use the floor boundary again. Even though I used it for the lights, it's fine to use it for something else as long as the overlap won't cause problems. And in this case, it won't, because the emergency devices are going to go to this new panel room, and the non-emergency lighting will all go to the other room. So when I'm done selecting service areas, I can cancel out of this. Let's just take a quick look at that attribute. So here, panel segregation, segregated other. It was changed to this by me answering yes to that dialog. Prior, it was probably defaulted to non-segregated. Because I had specified a segregated other type service area, it needs to be set to match that. So there's the circuiting. You saw that layers turned off to get them out of the way, to just leave us with the layers that we needed to concentrate on. To get those back, you can just turn all DraftLogic layers on, or use any of the other layer controls that you want to use. You might only want your lighting on, or just your power. But I'm going with all on. So before we run automated circuiting, the last thing to check is that you have a destination for your large motors. This is controlled by the setting in your motor parameters. Remember we set the cutoff to 2 FLA. So any motor that's equal to or larger than 2 FLA, here's where it's going to look to circuit to. So we need to make sure we have an MCC pre-existing in the drawing before we run automated circuiting that is a compatible voltage for any motors higher than 2 FLA if we want them to circuit automatically. If we're going to circuit them ourselves using the circuit manager, then it doesn't matter. So that's ready to go now. We have our circuiting schema set up. If we want to see what we've done, we have some tools to display the service areas. It shows us in green any panel rooms or panels that have been assigned service areas, and by clicking on one or many of those, here in this case I'll click on this one, right click to close the selection. It shows in blue, meaning other only, that that panel services that. So enter to return to normal. Back to choosing the rooms. So this room, I have blue for the southern other only areas and yellow for the floor boundary. So all my lighting for the whole floor plan that is non-emergency is going here, and all of the other type of devices for the south are going to that same panel room. And enter to get out of that and return the colors to normal. And again, I can use my frequent to turn everything back on. So there's tools there to display the service areas, to remind you of what you've mapped to where for circuiting. You can remove specific service areas if you change your mind about one or two or some. And finally, if you make a real mess of your circuiting setup and just want to start completely clean, there's a clear all service areas which will get rid of all service area, panel room, and specified panel assignments. If we're doing a reno job and we're dealing with pre-existing panels, we can use the panel status and spares tool here to modify what circuits are available for DraftLogic Electrical. So let's just say this kitchen, for example, I had some devices pre-existing in it, and I wanted to say, okay, these circuits are unavailable. So I'll say circuits number 1 to 8 are unavailable. Apply that. So now I can see in the top section for current designations that user designated unavailable is 1 to 8 and unallocated positions are 9 to 42. So automated circuiting will start at 9 and leave 1 to 8 all alone. Apply and exit. And same deal in a renovation job. I might want to say that there's some existing wattage here. Let's say I've got 2500 watts of pre-existing wattage on this panel. Okay, so now that we're done all of the circuiting setup, we're ready to run automated circuiting. You can just do that by clicking on the automated circuiting button. It asks me how would I like to select the objects for the circuiting job, and this is by panel room. So I would select a specified panel or panel room, and it would run just the circuiting for that area, or I can just do right click to do all of them. Depending on if the drawing had any operations run on it before, you might get 1, 2, or 3 questions here. First of all, if you'd like to remove any manual circuiting. So if you've done manual circuiting and you want to retain it, you can just say no and keep it. I'm going to say yes, I want everything started clean. If there was any pre-existing emergency circuiting, again, no to keep or yes to wipe it out. And if you had done any MCC or MDP motor circuiting, you can keep it by saying no or yes to wipe out. So what DraftLogic Electrical is going to do now is figure out a sort of salesman traveling path route between the spaces within each service area so that it doesn't cross over the travel path and so that the circuits flow nice and efficiently through the area. It also looks into neighboring rooms when allowed. You remember earlier we looked at the room library. There was a couple checkboxes at the bottom for each type of room definition. We marked with a check or an uncheck as to whether automated circuiting could share circuits between spaces or not. So that's also looked at during automated circuiting. Circuits are assigned in groups of 3 for a 3-phase panel or groups of 2 for a single-phase panel so that you get nice opportunities for neutral sharing down the road. and also nice circuit grouping for your panels and circuits. So here we are in just over a minute. Automated circuiting is complete. You can now see circuit numbers assigned to each device, and that there has been some branch circuit panels automatically placed. If you remember when we did our design parameter work, we specified some large panels and we said that we wanted them recessed, and that's what we were given. So here we have our B panel, which is the emergency one, and all of the emergency and exit lighting has been automatically circuited to it. Certain devices, like these battery packs, are not yet involved in automated circuiting, so it wasn't circuited. We'll catch that ourselves in manual circuiting. But other than that, we have our circuiting assigned. If you want to look at it by system, use your layer controls to turn the system off. So we have E1 flowing through these three rooms here, and then down E3 through here. It doesn't share into the corridor, it shares into the neighboring classrooms. And then finally E5, power, and finally motors. So motors, you'll remember we just filled in the horsepower. Well, based on that horsepower, the load and the FLA were calculated. There was protection decided upon and circuiting decided upon. If you want to change the horsepower that was used for automated circuiting and rerun automated circuiting, clear all of these values out, clear the load, clear the full load amps, and change your horsepower, and then rerun so that these get recalculated. Your parent protection assignment will not change unless you use the circuit manager to do it or you rerun automated circuiting. Just by changing this arbitrarily right now, it means nothing. My protection will stay the same through all future processes. It's only during automated circuiting that DraftLogic will change it for you, or using the circuit manager, you change it for yourself. As with the other automated processes, automated circuiting will place arrow and warning arrows when it finds things that it can't deal with as well as it would like or can't deal with at all. So using our zoom to first arrow tool, we have here a stove rated at 240 volts. Well, in our design parameter, we didn't allow any panel that supported 240 volt equipment. So what we can do here is change this to 208, and we could either rerun automated circuiting or we can use the circuit manager. So if I go to my next error, there's another stove, 208. Get rid of that, and let's use the circuit manager and fix those stoves up. Zoom to next error. I can message here, no error pointers found. There's no more left. So just the two. So going to the circuit manager, first let's deal with the kitchen. We know that's panel A. You can see in the summary section here that DraftLogic circuited circuits 9 through 17, put some spares in, and didn't touch 1 through 8. So by looking at this slot to use dropdown, we can see that user designated unavailable, so they weren't used. For our stove, let's put it in at 18, and this will be a couple for our stove receptacle here. Just as in the other processes where we're building a selection set, you click to add. When you're circuiting, if you right click, you get a running total of the circuit load. Right click again to close that selection set. You're back to the circuit manager, and it tells you that it's added the KND, so kitchen D receptacle is the name of that, rated at 6,000 watts, and that it's a kitchen special receptacle. And here's the calculations where it applied the safety factors that you asked for in the project parameters and that are in the building code. And finally, that it selected a 40 amp molded case breaker for that circuit. So for the next one, let's look and see what everything else was circuited to, panel F. So let's go to panel F. It goes to the first available by default. Couple poles, add objects. Now, DraftLogic Electrical will filter based on your selections in that circuit manager dialog. So if I say I want to do a receptacle 2-pole on a 120/208 panel, but I choose a 277 volt light, well, first of all, I'm told select a standard or split receptacle or motor objects, and it didn't even let me select that light. Now, on the other hand, if I select a receptacle, right click, I get a warning. The selected equipment voltage does not match the panel, unable to add. So watch the command line for these warnings about issues with your attempted circuiting. Finally, I select what we really were after, right-click, get the load running total, right-click to close a circuit. Back at the circuit manager, it lets me know that it's done. And finally, I can look at my emergency equipment. So here I have a bunch of lighting on that emergency panel, the B. Some of these dialogues, you can do certain AutoCAD operations while they're open. Like for example, I can open the attributes and see that B is an emergency panel, 277 volts. Let's take a look at our emergency floodlights. When I place them, I put them in at 120 volt voltage. Since I want to circuit them to the same emergency panel as the other equipment, I'm going to change them to 277 volt one phase. There's actually a quick way if you want to make that change to a number of devices. If we look at the AutoCAD properties, you can see the 277 volt voltage value here. I'll just copy that and add the other battery packs to the selection set. So you can see now for all three of those block references that the voltage varies and the phase varies. I can change the voltage to match that. Get out of this properties manager and check this one with the attribute editor, and now everything is as I wanted it set. So I don't actually need to go into each and every block with the attributes editor if using the AutoCAD properties or the AutoCAD quick select with properties will enable me to make a mass change that still gives me valid data. Important to make sure that you get the format of that data exactly correct when you do things like that though. So here we have our B panel. It's automatically gone to the first available circuit, which is number 6. So we can add our single pole lighting with these battery packs on the circuit. Right click to close the selection set, and now it's showing me that the circuit is done. You can see these prefix numbers here, 1, 2, and 3 in the objects and circuit list. They're the same numbers that you see as suffixes after the circuit number in the drawing. They're temporary, so if I close out of the circuit manager here, you can see they disappear from in the drawing. They're just to let you know which object is which in the list in case you wanted to remove one or change it. So that's automated circuiting and the circuit manager. The circuit manager will take care of changes that you make automatically. So for example, if we wanted to leapfrog receptacle circuits in the library, right now they run in order around the room, as is the standard setup. We can go to the library, we see we're on circuit G and we have 40. We have some availability on G up at 44. So I can just take every second 40 instead. Close that off. And now you see we have leapfrog 40 and 44. If we go back to 40, it has automatically modified circuits that were involved in that and the total wattage. So it's taken them away out of 40, and when I put them in 44, I didn't have to go and remove them from 40 myself. Your later selection overrides your prior selection, and the circuit manager takes care of those alterations for you. The other thing that we need to use the circuit manager for is to finish up our distribution, or as we call it in DraftLogic Electrical, our power tree, because we include the distribution devices and the branch circuit panels. So for a sec, I'll close off my circuit manager, go to my distribution and mechanical tool palette, look at my main electrical room. Earlier we had placed the MCC we needed for our motors and our main distribution. Now we need to gather up all of our 12208 product to a CDP, and then from that center distribution panel go through a transformer to get service from our MDP. When you're selecting a transformer size, select the size that you think it'll approximately be. DraftLogic Electrical will calculate the kVA for you regardless of which block you choose. So really you're just looking to choose something for the physical size you want to represent in your panel room. My primary voltage needs to match my MDP. Secondary needs to match the children that I want to circuit to it. Now what I'm also going to do is for this emergency panel here, I'm going to add a generator. Now our single line supports most of the distribution devices, but not transfer switches at this time. So instead of a transfer switch, I'm going to place a splitter, and you'll see why once we get to the single line. But for now I'll put the splitter in, and I'm going to name it as though it was a transfer switch. Okay, so now I think I have all the distribution devices I need, and I can use my circuit manager to create the relationships between them. You can create these relationships from the top down or the bottom up, whatever makes the most sense in your mind. I'll do a top down selection. So for my MDP, I'm going to choose a child panel, which I'll grab my transfer switch first here. Devices that we only allow one of for a relationship, you don't have to close the selection set off. You just choose the one device and you're back at the circuit manager. And you can choose next unallocated circuit. You automatically go to the next available. I'll choose that transformer now. In the drawing, pan back to the main electrical. Select the transformer. Next unallocated circuit. Now my lighting on panel E is also 277, so I can take E directly to my MDP. And then I can work my way down from there. So I have my transfer switch, which I need to pick that emergency panel up for. And I have my transformer, which I need to pick up that central distribution panel. And then from the central distribution panel, I'll pick up all my 120/208 product, which includes this motor control center, the kitchen panel, and all of these other receptacle and small motor panels that were in my drawing. Now if I forget to do next unallocated circuit and I just say add objects, I'll get a warning. Child panel circuits only allow a single panel. Please remove before circuiting a different one. This is true for all but meter centers. Meter centers, if you want to have the suite D rating work, you apply all of your suite panels to the first circuit on the meter center, and that triggers the suite D rating code. But for all other purposes in the distribution, it's a single device per set of circuits. So we do the next unallocated circuit and then add those remaining panels. There's a couple checkboxes on the circuit manager. If you turn them on, it'll automatically zoom to the child and the parent at the same time. I have one for the parent up here and one for the child here. So you can see once that circuit is complete, it zooms a drawing and flashes both the child and the parent. On the other hand, if I take the parent off, go to a prior circuit, it automatically flashes and zooms just the child, or child off, parent only. Flashes and zooms just the parent. So if you're not sure where in the drawing these things are, you can use the zoom extents button. If you have multiple devices in a circuit, for example, let's look at our E panel, which is a lighting one. We'll go to one of our lighting circuits and say zoom extents. So it flashes and zooms to all the devices in that circuit. Fastest operation, of course, is with both of the zoom extents checkboxes off. Okay, so I've circuited all the devices now, and we're ready to proceed to the next phase of work. If you desire, DraftLogic Electrical will also figure out multi-circuit branch circuit wiring home runs for you and draw all of the branch circuit wiring interconnects between the various devices, deciding on wire sizes, wire counts, and placing your home runs for you. You control the automation through the parameters, and you can also draw your own detailed branch circuit wiring or modify the automated branch circuit wiring using the Branch Circuit Wire Manager. Branch circuit wiring is optional. You don't need to do it for any of the reporting purposes unless, of course, you want to have a complete bill of materials or do an export to IntelliBid. In those cases, of course, you'll need to do all of the branch circuit wiring. Some of you, for some projects, might want to run the branch circuit wiring to get your home runs and home run arrows all figured out and put in the drawing, and then just delete the interconnecting lines if you don't want to show those, and you'll end up with nice, accurate multi-circuit home runs for your floor plans without the branch circuit wiring interconnecting lines cluttering up the floor plans themselves. As we talked about during the libraries section of this quick start video, the branch circuit wiring automation is controlled by your selections on the branch circuit wiring parameters, which we'll take a quick look at in the project library. So here we have the branch circuit wiring parameters. The most important ones, of course, are the maximum circuits for home runs and the maximum voltage drop allowed for branch circuits. You can also change the percentage of protection amps to be used in the branch circuit voltage drop calc. Your wiring method can be conduit and wire, non-metallic dry, or armored cable. And it's separate for the actual branch circuit wiring interconnects versus the home runs. So for example, you might have conduit and wire for the home runs, whereas you might have armored cable for the interconnects. I'll leave both of mine to be conduit and wire. There's also some parameters in the power tab that affect how many receptacles will group together for an overhead junction box, and how far the automated branch circuit wiring is allowed to look for receptacles to group together. To run automated branch circuit wiring, just select the full cycle BCW command. The auto only and pre-processes have very specific uses. You probably won't use them at all or very often anyway. So full cycle branch circuit wiring. First, we see a dialog asking if we want to run the load calculator. In order to create the home runs for motors, branch circuit wiring needs to have the feeder populated on the large motor blocks. That won't have happened unless you've run something that sets those up, which is any report that uses them, like a motor schedule, panel schedule, or single line. We haven't done that in this sample, so actually we do wish to run the load calculator. I will click yes here. In the case where you have recently run a motor schedule, panel schedule, bill of materials, or single line, then you don't need to. You can just say no. Next, we're asked which objects we want to revoke. Automated branch circuit wiring doesn't accommodate for existing branch circuit wiring in the drawing. So you need to either avoid the areas where you've done some work that you want to keep as is, or wipe it all out, which is what this is asking. So if you have information that you want to keep, you can cancel out of this or go ahead with it and just select the areas you want to wipe out. In my case, though, I want to start clean, so I'm just going to select manually placed, say OK. Next on the command line, I'm asked how do I want to select for the revoke. I'll just right click to do the default all, clean my entire drawing out of branch circuit wiring. Lastly, we need to tell DraftLogic Electrical which circuits we want automated branch circuit wiring to run on. We have 4 choices, as you can see on the command line. We can select all, which is the default. That'll perform automated branch circuit wiring on all circuits in model space. A polygon, where we can choose any closed polygon, and only the circuits represented inside that polygon will be run. By room type, wherein only circuits within that particular type of room will run. Or select, where we can select an area using crossing or block by block. Now remember that if you select any block of any circuit, then the entirety of that circuit will be run. I'm selecting all. So here we have our branch circuit wiring complete. It ran the load calculator for me. It did the revoke, and then it ran branch circuit wiring all in one fell swoop. So you can see, for example, I have my motors with the home run set up. Feeder was selected by the load calculator, and then branch circuit wiring created the home runs for me. I have home runs for my lighting. They were gathered into multi-circuit home runs. Here's where the layer controls come in really handy. You can also draw your own branch circuit wiring, of course. Let's just switch to the power system here and do some of that. So for example, I'll get rid of these and draw those. Now you can just select the proper layer manually and draw polylines on it. That's XDL recept con for conduit. Or you can use a couple of tools that we have. So first of all, we have a manual assist which will set the layering up for you. So we'll do this overhead conduit. Blocks have snap points, tiny little circles to snap lines onto. And right click to close that off. So you can see that by using that command, which is now cycling again, I escaped to get out of it. By using that command, it automatically selected the layer based on the block that I first started the line at. If it was confused, for example, if I do this under slab starting in the middle of nowhere, it asks me which system I want that under slab for. And you just use the first letter of the system, and then you get branch circuit wiring for that system on the layer for that type of branch circuit wiring for that system. So I'll just delete that. We also have a semi-automated tool which will do the routing itself. You just choose the start and end point and it'll route it for you. So if we do this semi-automated conduit here, we're asked for the first block and then the second block. DraftLogic Electrical routes based on its same routing rules it uses during branch circuit wiring. Escape out if I don't want to do any more. Now regardless if the line was created with semi-automated branch circuit wiring like this one, or completely automated branch circuit wiring like this one, you can see that there's a number of extra grip points that have been included to allow you to reshape the lines. So if we didn't want that extra jog in this one, for example, we could decrease the number of vertices and make this line up. That's what the extra grips are for. And then finally we need to put the right data on these manual lines we did in order to ensure a good bill of materials and ConEst IntelliBid export. To add data to lines that we drew manually or to change data on lines that were drawn for us, we use the same tool, the branch circuit wire manager. The first thing it asks us is to select the object. Which line do you want to work with? Well, let's take a look at this existing line first. We're told that this is a receptacle conduit, that the AutoCAD line distance is almost 8 meters, and that DraftLogic has calculated the distance to be about the same, which makes sense. It's an overhead junction box to an overhead junction box, pretty well straight line connection. So the DraftLogic calculated distance shouldn't vary much or at all from the AutoCAD line distance. The conduit size that's been assigned is 3/4 inch, and we're advised that the fill in cross-sectional area is 23.22 of the maximum allowable 137.6. This is driven by that 40% maximum conduit fill parameter that we specified in the branch circuit wiring parameters. Inside that conduit, we have two wires, both number 12. We have G1 panel hot and G1A neutral. So that's the same that we need to feed these other two lines here. So now we can select one of our new lines, give it the same size and wires that we're in, what it connects to. And I have a dialog here advising that no line count block was found to update, so therefore a new one was created, which is the specification of what we needed, one hot, one neutral. We select our other line and do the same. Before we do that, however, let's cancel out of this and put an incorrect wire count. The wire counts snap and rotate to the nearest branch circuit wire line. So I can click just out here. It'll find the line, change to its layer, rotate and snap to it. So back into our branch circuit wire manager, select that new line, and let's change it to be the same as we have elsewhere for this circuit. So populating these lines manually does go fairly quickly, but of course it's a lot faster if you can leverage off of what the automated circuiting has done for you. So we apply this, and you can see that the wire count block was found and fixed for us. So you saw a propagating changes dialog that showed up. That's actually a very powerful part of the BCW manager. Let's take a look at it in action. We'll go to our lighting, layering. I know that this E3 circuit touched on quite a number of devices. It does the lighting for all three of these classrooms. So if we wanted to change our E1 circuit to be a different wire size, for example, not something you might do in reality, but I need to show you this tool anyway, right? So I'll bring up the branch circuit wire manager, which is available on the BCW tool palette or on the command tool palette in the BCW area. We'll pick any one of the lines that E3 is involved in. So this little fixture whip here will do just fine. Now by default, the size change propagation is on. It will propagate wire size changes to the entire drawing. It'll upsize conduit when required because of a wire size change, and it'll downsize conduit when possible. Now that, of course, the downsizing will not go below the minimum conduit size that you asked for in the BCW parameters, so no worries there. So let's say that we want to change wire size for circuit E3 to be larger. Again, I know this is not proper engineering, but I do want to just show you this, so we're going to do it anyway. So we're bumping up the switch leg hot and the neutral to number 8 here for E3A and E3. So we apply that. So here we are after the changes were propagated back at the branch circuit wire manager. And it added a wire count block to this one automatically. If we don't want it because of the shortness of the link here, we can just delete it. No harm done. Let's take a look at some other E3 branch circuit wiring interconnects and see if that propagation happened properly across the whole thing. So we'll just select one far away here. So we have the E3A switch leg hot and E3B neutral. Both have been propagated, changed up to number 8. So if we go look for the home run, just to see if that was altered correctly, we go over here, find the home run, and we find that E3 was bumped up to a number 8, even at the home run, as was its neutral, whereas the other circuits in the multi-circuit home run, their hots stayed at the originally assigned number 10 and number 12. Obviously, E1 and the original E3, because of their distance from the panel, had some voltage drop, kicking them up to number 10. Now, with the inclusion of the branch circuit wiring and the home runs in the drawing, you can see we have a lot of clutter, especially if we turn all the layers on, but what's most important, of course, is the readability of our plots. So system by system, you can see we have a fair amount of clutter, especially where the home runs are concerned. So we have a tool to deal with that automatically. Instead of making you sift around and touch thousands of circuit numbers and move them around to more aesthetically pleasing places, we have what's called the annotation organizer. So in the systems placement area, you can just select the annotation organizer. Now these are in drawing units instead of in inches or feet like all of the parameters, because once we're in the drawing, most of our distance inputs are in drawing units. For example, the ceiling grid, we did that in drawing units, and also for the annotation organizer, we'll use drawing units. So buffer distance is how far to have empty space between annotation elements, which is the visible attributes, and the blocks and other things from the same collision group. A collision group is stuff that ends up on the same floor plan typically. So I'll use 40, attributes height, typically 200, and attribute spacing, typically about the same as your buffer between the attributes and the blocks, or branch circuit wiring lines, for example. Switches are separate because you might want them to be a little smaller and tighter. So I'll use just a bit smaller numbers for those. Now some options. Do we want to run our annotation toward the wall-mounted blocks instead of keeping it all at 0? So I'll say yes. And in the case where we do that, do we want the attributes for horizontal blocks to be forced to 0 or still to be turned toward the wall-mounted? So I'm going to say no here because I still want them to match their rotation to the actual wall-mounted device. And for that annotation that is matching the wall-mounted device, do I want the text to run southward or northward? So yes, no question there. And do we want to treat wall-mountable devices as such even if there's no room boundary near? So for example, if there's a counter in the middle of the room with some plugs on it, do we want to run the annotation towards those wall-mounted or at 0? So I'm going to say yes here. And do we want the annotation to try and avoid the XREFs? I'll say yes also. Use selection is if I want to run just some annotation, which I would select, or do I want to run the whole drawing? So for use selection, I will say no. And last question, do I want to perform for the home run blocks only, yes or no? I want to run everything, so I'll just say no here. On the command line, we see some performance statistics for the annotation organizer. It tells us how many blocks it processed, how many home runs, and then how long it took. In this case, about 71 seconds. And it also marked with warning arrows where it wasn't able to move things around to its satisfaction. So for example, in this area here, it was just too cluttered for it to move the attributes around. Let's use our layer isolation. Isolate the power layer. You can see that the wall-mounted blocks had their attributes put in line with them. And in this case, the home run was moved here. These look close, but if you do a distance between them, you can see that it's within or over the range that was specified for the buffer distance. So if you want things to be further apart, you'll need to specify a larger buffer distance than I used. So in most cases, the annotation has been cleaned up to prevent overlaps, and in the case of the wall-mounted blocks, by orienting to the wall-mounted device's rotation angle, they actually take up less space overall. As with all automation in DraftLogic Electrical, we're not looking for the end-all be-all 100% solution here because that would take many years and years to program and cost way too much. We're looking to deal with everything that can reasonably be dealt with automatically and leave only the more complicated situations for you to deal with on your own. So there we have branch circuit wiring. The lighting, receptacle, and motor systems are all automatically handled. Other systems, like for example emergency floodlights for now, communications and other low volt type systems, and fire systems, you'll need to manually draw your branch circuit wiring or use whatever processes you currently use. If you use DraftLogic Electrical's layering and the branch circuit wire manager to populate the information on the lines, then the bill of materials and ConEst export to IntelliBid will capture that information for you. DraftLogic Electrical's robust reporting facilities are where you take advantage of all your prior work within the DraftLogic Electrical system. All of the reports are completely automatic. They're generated from scratch using standard AutoCAD blocks and layers. So when they're complete, you can copy, paste, move them from layouts to model space. You can export them to their own DWGs and use them as XREFs. You can resize them, rotate, whatever you desire. There's also an immense amount of information in the drawing usable for AutoCAD data exports if you wish to extract anything out of your DraftLogic Electrical drawing. Whether you decided to run the automated branch circuit wiring or not, as long as you created your power tree So put down the distribution devices and use the circuit manager to create the relationships between them. You're now ready to run reports. Before we run floor plans, however, we need to go to our command tool palette. At the bottom there's a reporting section, and we have a define plot area button. The plot order is just the order they're going to end up showing up in. This is an arbitrary cut line for a floor plan. So for example, if I wanted to cut this school into 2 pieces for reporting purposes, again using C to close that polyline, and I'll do my second piece with a bit of overlap so that they each have some context on each side of them. And now I can launch my report wizard. There's a list of reports for you to check on which ones you want. The typical batch is checked on by the All Reports button. And before you run your reports, if you want the XREF to show up in your floor plan, make sure you can see it. Make sure it's on before you click OK here. I'll turn off my reuse prior plot settings checkbox because I want to show you the printer and paper size selection. First we get the plot dialog, and if this is your first use of DraftLogic Electrical, nothing will actually be expanded on. You'll just get this ACAD printers, hit plus to expand the list, and then any printer that you want to take a look at the available paper sizes, you'll select it, and as soon as the paper size list is populated, you can hit the plus. I'm going to use the DWF ePlot, and I'll go to my eSize. Next, I'm asked if I want that to be a portrait or a landscape, so I'll flip it to use a long orientation on the landscape. And now my reports batch is off and running. The validation tool runs first, letting you know if it needed to clean anything up. After you OK that, the entire batch will run through uninterrupted. So in just a couple of minutes, our reports batch is finished. The Operations Center comes back up to let us know everything's done. We can just minimize that or close it out. Watch out, because if you click OK on it, it'll go again. So we have a number of reports. The single line being intact lets us know that we did what we wanted to in terms of associating the distribution devices using the circuit manager. Here's where I use that splitter and call it a transfer switch. If I want to have it not say splitter at all, I can just burst it and change this, either delete it or change what it says. And then further, I can extend this down and add my generator in by just copying and pasting some elements that are readily available here, changing them as desired, and finally going to the single line tool palette to get the generator. Now the generator will come in at a massive size, but by looking at the scale of the other blocks using properties, just copy it. I can make the generator the same size as everything else. At some point in the future, of course, we'll have that automatically happen. So there you go. The single line was almost completely automatically generated. I just had to add my generator and alter my transfer switch appearance a bit. Other than that, all of your lengths are calculated automatically, bonding and grounding, feeders, protection types, also all your panel schedules. Now if you want your panel schedules to show up on your floor plans, like we talked about earlier, these are just completely standard blocks, so I can just copy this and go to my floor plans, paste it here. I can move it, scale it, everything that you do with a standard AutoCAD block and layers. Here's our complete bill of materials. So all of these reports are explained in detail in the reports video. Let's look at some special situations with the reports though. If you go to the directory that your drawing came from, some of the reports end up in there. So our Quick Start Rooms and Grid BOM Excel version is put into the folder that the drawing came from. No special formatting, but everything is here same as it is in the DWG format, ready for you to manipulate as you desire in Excel. There's also a bill of materials log if you're wondering what was used to make up the bill of materials. This log details every item that went into making the totals for the bill of materials. And also there's a fault levels log, which shows you in detail how the fault levels were calculated for each distribution device, including motor contribution. There's one additional report, which is different than the rest. You can access it from the Operations Center Reports tab or from this reports list here off the DL Electrical menu. It's called the Export to IntelliBid. What this does is it goes to your ConEst IntelliBid database, lists all the jobs there. You select the job you want to export to, and if you've recently run the protection and feeder recalc, which we also call the load calculator, that runs on any execution of panel schedule, single line, bill of materials, motor schedule, or kitchen schedule. So of course we've just run it now. We don't need to check that off to rerun it here. Click Export. DraftLogic Electrical parses through the drawing and grabs all of the detail and pushes it into the ConEst IntelliBid count sheets completely automatically. And that includes every single tiny little branch circuit wiring interconnect is fed individually into the count sheets. So it'll save your estimators immense amounts of measuring, scaling, counting, and mouse clicking and keystroking. So after a couple of minutes, you can see that the export to IntelliBid is complete. Any warnings are listed at the bottom. And you can see the quantities of items that were pushed into each of the count sheets. You can zoom to warnings that have a specific object or not, like this one. And if we go into ConEst IntelliBid, we can see by going into the count sheets that all the information has been pushed in. Here's the quantities of our luminaires. And for example, we can go into the switchgear branch circuits, for example. It's color-coded for the multi-circuits, and you can see the individual interconnects for the branch circuit wiring that has been fed in here in this dialog. That's it for our high-level overview of the reporting features. Congratulations! You've made it to the conclusion of the DraftLogic Electrical Quick Start training video. In working with a variety of clients throughout our time at DraftLogic Incorporated, we have found that there are 3 keys to being successful with DraftLogic Electrical. Firstly, your company must allocate you paid time during workdays to do the training. Asking you to do it on evenings or weekends or just to fit it in during your regular work schedule will probably not work. You need to have dedicated time to go through the training and try things in order to actually learn how to use DraftLogic Electrical and at a minimum double your productivity and not be frustrated in the process. Secondly, you really need to go through the entire training video series. Today's quick video was just enough to get you started and hopefully whet your appetite. Within the next couple weeks, while your memory is still fresh of today's training, go through the other training videos. The additional knowledge you gain will directly benefit your electrical design productivity. The last key to success is probably the most important one. You cannot spin your wheels. What that means is whenever you find yourself unsure of how to achieve something you need to get done in DraftLogic Electrical, reach out and ask for help. We're available by email, by chat, by phone, and through our forums. So depending on how timely the question you have is, pick the method that best suits it and reach out to us. The few minutes you spend on the phone with a DraftLogic Electrical support representative will pay off much faster than spending a half hour or more trying to figure out something on your own. Now that you're done the quick start video, take a look at the video training manual and you can see all the other videos we have to offer with recommendations on the order to watch them in and on some sample data that is relevant to each of the videos. Let's take a quick look at the DraftLogic Electrical Forums, where you can look for answers to questions that others have asked before and also post your own new questions. Please remember that the forums are for questions that you don't need an answer for right now. If you're working on something and you would benefit from having an answer immediately, please just give us a call. You can get there a couple ways. There's a direct link to it, or you can just go to draftlogic.com, and there's a link both on the front page and in the support menu. Here's the front page link, support forums, or you can get to it here. Now, if you want to log in to respond to or enter new items, you would do it here. You don't need to do that to just browse. So for example, you can go into the room and floor recognition details section, and here's the questions and answers related to that phase of work in DraftLogic Electrical. If you do log in and enter an item, you can expect a response in as little as an hour or so, or as much as 1 business day. So this medium is great for questions you aren't in a rush to get answered, or if you have something you want to ask on a weekend. So here's the various categories, and the question and answers associated with each category are listed here, and just by clicking on the name, you can get extra information. Everyone at DraftLogic would like to thank you for your time in watching this video and in learning how to use our DraftLogic electrical software. We truly want you to be successful, so please call, email, chat, or go to the forums if you have any questions whatsoever.